A few words on analytic hierarchy process again. And as I said, this analytic hierarchy process is a method for, as we said, subdividing a complex decision into a sequence of sub-decisions, and it's a method to combine several criteria. As it is, it's not necessarily a robust method, meaning that it doesn't necessarily take into account uncertainty. However, if it is used within the context of decision scaling or robust decision making, which means if it is used for assessing the performances of the system, assessing several alternatives with respect to multiple futures, then it becomes robust. And therefore, I hope that in this way I can convey what is the essence of the robust methods and what is the role that can be played by a subdivision in a hierarchy of decision in the context of robust decision methods. That's it. Now, I would like, together with you, in this remaining 40 minutes, to do two things. First, I would like to make a recap in the form of possible questions that I may ask at the exam. So my proposal is to go back to our list of lectures and highlight some possible questions. I think this is very useful for you, which doesn't mean that necessarily I cannot ask any more questions with respect to those that I mentioned today, but it's a way to give you an idea. And so let me go back to the website. So, first, there was a premise, the learning process adopted in the course. There are no questions about it. Then we talked about sustainability in the 21st century. I don't remember if I turned the camera on. Just one second. Yes, I turned it on. And I would say that here, it's of course an essential premise, but I would say that there are no relevant questions that can be asked about this lecture. And I think it is very unlikely that I may ask you something like, what is sustainability, how would you define this? It may happen. Just I think it's important that you read this. It's something to read rather than to study. Possible questions, unlikely. Maybe like, what is your definition of sustainability? When was sustainability born as a concept? Things like this. And as I said, it's something to read and not necessarily to study. I wouldn't say that there is sustainable development goals. There are no questions about these. I think it is important that you know this, and it's important that you know that engineering, of course, it's something that is important, but it's relevant in this context. But I wouldn't say that there are any other questions related to it. And let me just check here. Then here there is virtual water, the concept of virtual water. I think this is something that, besides definitions of sustainability, brief history of sustainability, besides that, I wouldn't say that there is anything else that can be. Sustainable management of water resources, even in this case, I would say that it's very important information, but I wouldn't say that there might be questions related to this. Costs, water demand, possible solutions, I wouldn't say that. Okay, so let's move forward. And here we come to the one of the most important lectures, inductive methods. Okay, here there are some some analytic questions that I may ask. First, let me make a difference. I may ask during the exam descriptive questions in order to assess your ability to speak. A descriptive question may be, what do we mean by sustainability? It means that you need two things in order to reply to a question that is descriptive. You need some basic knowledge, and you need to speak well. So, if you don't have an idea of what sustainability is, it's difficult for you to reply, and you run the risk of replying by saying unrelated things, because of course it's easy to talk about sustainability, but if you want to be rigorous, you should define what does it mean sustainability in the context of water resources management, what are the threats like climate change, increased demand, what are possible solutions, so increasing water resources availability, demand control and regulation. Of course you need to know something about these things, which means that you need to have read these lectures. And very important, you need to speak well. The two things are related. Usually one speaks well if one knows what is speaking about. And usually once that you know what you are talking about, you are also able to convey the concept. But pay attention to speaking well, which doesn't mean speaking in a good English. English, it's not our native language, because maybe there are few exceptions, but I don't think so. There are native speakers here. No? Okay. So we are not pretending that it's our native language. But I can tell you that your ability to speak is independent of the language. If you have a good knowledge of the English, and your ability to speak means that you have to go to target. So if I ask a question, you shouldn't start from the prehistory of the humans. You should go to target quite rapidly, and you should provide a concise reply, but on the other hand, an exhaustive reply. So you should say everything is relevant, but not more than that. And this is something that you can manage if you have a good perception of what you're talking about. This is for the descriptive questions. For the analytic questions, it's still important how you speak, but it is easier because even if it seems counterintuitive, it's easier to reply to an analytic question than to a descriptive question, because to an analytic question the reply is very well defined. So if I ask you what is the flow duration curve, it's very easy to reply. Of course you need to have studied it, and I say studied because it's an analytic question, and therefore you have to probably give proofs, elaborate mathematical demonstrations, so you need a preliminary study. But on the other hand, if you studied, it's very easy to reply to an analytic question, because you may also write on a paper without talking, which is in some cases fine. To reply to a descriptive question requires an ability to speak that needs to be taken care of. So, going back to inductive methods. Here, it's a ground for analytic questions. And for instance, a typical question is, what is a flow duration curve? How do we estimate it? And you know that there are two methods, pulling together the information or computing the flow duration curve for each year. And there are pros and cons for advantages and disadvantages for each of these two solutions. So it's nice that you are able to say that if you split in individual years, you can estimate uncertainty. If you pool the data together, you can have a better definition of the flow duration curve, but a finer definition, but on the other hand, you don't have an estimate of uncertainty. These are things that you need to reply to. And also, about flow duration curve, there is a reasoning on these regimes and flood flows. So I may ask you, does the flow duration curve provide the information on flood flows or not? and you have to reply that yes, no, depends on how it is estimated, and everything is explained here. Design water withdrawal. What is the typical design water withdrawal based on the flow duration curve? And we said duration from 30 to 60 days. And another good question is this diagram, how to estimate the volume from the flow duration curve that is withdrawn. What is environmental flow? Another question. And this is not very analytic. I would say it's descriptive because I didn't give you any method for computing the environmental flow, but I explained what it is. River barrages, no, okay, here it's too early. Okay, that's fine. And there is also, yes, I could say for groundwater, what is the way to make inductive assessment? And inductive assessment is through aquifer testing, through wells, and therefore this is another possible question. Okay, let's move to deductive methods. Here there are some typical questions, and linear reservoir with the mathematical development. Please study this proof, and look, it's not a big problem if you describe the linear reservoir but cannot make this mathematical development integration. But beware that saying no to this question means 3 marks less. So it's, I wouldn't give more than 27, even if you make a perfect exam, but you skip an analytical proof that I am requiring, like this one. And this is something that you don't need to learn by memory. You just need to learn by memory the assumptions, but then can be developed by writing on a paper and keep into account how the exam is structured. So I make the exam to 2 persons at a time, and therefore your first question may be written down. So your first question may be like linear reservoir, and you need to write on the paper and then to explain to me later on. If you have any question while I'm talking, just okay, step in. And linear reservoir. IMOD is something that I may ask. There is an analytical development that is a bit complicated, and to explain how the model works is a bit complicated, but usually when I see that the student is well prepared, this is a question that I ask quite frequently. Okay, and then there is calibration, I think. Our groundwater models, yes, the groundwater equation, this is something that I may ask, the groundwater flow equation. And that's it. Model calibration and validation. Typical question is objective function. Please write down what are the objective function that we considered. And another typical question is calibration procedures. Just speak about it. Trial and error, manual calibration, automatic calibration, advantages, disadvantages, etc. And it's in this case, keep into account that if I ask a question which is descriptive, like tell me about calibration, and try to be ready to provide an organized reply. There are several things to say by keeping a concise reply. As I said, trial and error, automatic procedures, etc. And calibration through expert knowledge, this is also something that is interesting to say in a descriptive reply. Validation, this is maybe another question. What is validation? What's the difference between calibration and validation? Okay, river barrages. A typical question that I ask here is depict a sketch of a river barrage. What I'm expecting is this one, and point out what are the most important elements of a river barrage. And then you have to make a sketch like this one. And what I can ask is, in an analytic way, in an analytic context, elevation of spillways. So you need this formula here. Usually I don't ask the stocks It was you that pointed out that, yeah, sorry, I didn't have time. Yeah, you're right. And I realized that it is, there was another student telling me the same thing. There is an exponent missing here, but I make the change. In any case, so for the other students, there is a minor, but there is a mistake here in this demonstration. I need to correct it. I'm planning to do it in the weekend. And in any case, it's unlikely that I ask you this proof. It's very unlikely. What I can ask you is how to size the scent trap, but by assuming that we know how to compute WS, which is the velocity, the vertical velocity of the particle. And usually I don't ask it, and I didn't prove it, and therefore I don't ask it. Design of the head tank, upstream tank, also this formula here, it's important to know, and also the Blig-Lane relationship here, this one. This is something that I may ask for computing the depth of the barriers to be built in order to avoid infiltration under the barrage. Okay? You know, climate change and water resources, it's very unlikely that I ask something, because, you know, it's a lecture where the important message is the order of magnitude of the changes that occurred in the climate. I would say that it's important that you know this order of magnitudes, which is temperature 1.1 degree, and for sea level rise is 15 centimeters, and for extreme rainfall there is a relationship, it's about 6% increase, and just it's a good thing if you know these orders of magnitude. It may be that during the exam, maybe in the context of another question, it is useful for you to know this, but it's just a matter of orders of magnitude. And therefore, I wouldn't say that there is much more that can be asked. Let me see this lecture, because I remember there is one thing. Yeah. Methods for assessing human impact, perceptual assessment, and assigning priorities, and methods for assessing the effect of each driver, historical data analysis. Yes, this is something that may be asked. I don't ask usually to go into the details of linear regression. Okay. Let me talk first about saltwater intrusion. This is a question that I frequently ask. So typically I ask how to determine the position of the interface. So this sketch here. And also another question may be, what are the drivers, what are the causes for saltwater intrusion? And you may reply by mentioning the fact that there are large-scale drivers, regional drivers, local drivers. And this is interesting if you can reply in a structured way. And from the analytic point of view, there is this computation here of the position of the interface. Now, for decision theory, I would say that for the first exam, nothing. Later on, if you take the exam later on, pairwise comparisons, that's it. Okay? No more than that. About the exercises, I already mentioned to you that I'm not asking anything related to them. And of course, it may be useful for you if you know what we did, because you may say during one of your replies, like we did in the exercise, which is a good way of showing to me that you are aware of the exercises and you made them. But it's usually I don't ask anything related to these exercises. It may happen, it is unlikely, it may happen that I ask you to develop a short exercise, but not related to those we did in the class. Or maybe related, but not of the same complexity, because these are a bit complex. So a short exercise may be like, I give you 10 numbers and I say depict a fluctuation curve from these 10 numbers by assuming that 12 numbers, by assuming that they are monthly data, and it is quite easy to write it down. Easy but not immediate. This is the reason why I ask these questions sometimes is because I want to check whether, besides your ability to explain the concepts, you also have the ability, which is typical of the engineer, to translate the concept into application. So if I give you 12 numbers and I tell you these are monthly average flow data, can you please depict the annual flow duration curve from this? It is an easy question if you thought of it. If you have to think at it during the exam, it's a bit... I feel that if you made exercises and you got a feeling of what is a flow duration curve from a practical point of view, it's easy to apply. Otherwise, you know, it's a bit, or like giving 53 numbers and saying these are weekly data, and depicted the flow duration curve, annual flow duration curve for this year. You know, you have to think a bit about it. And you have just to think about the horizontal axis, how to put in an annual scale 12 monthly data. It's not difficult. I mean, you may think that it's trivial, but still. And this is an example of an exercise that I may ask you to write down. Okay, so that's it on my side. Now, let's take the time that is needed to question and answer. Anything you have in mind? Exam, today's lecture, overall course.
What do you say about the pairwise comparison for the first exam?
First exam, no. Decision theory, nothing for the first exam, okay? And for the, let me say that for the subsequent dates, I said pairwise comparison, meaning that it's just enough if you know how to resolve the exercise that I proposed to you. It's just enough. And not going into the details. So, for instance, checking consistency, it's just enough if you tell me that basing on the eigenvector of the matrix, you get the weights, and basing on the eigenvalues, there is a way to check consistency, no more than that, just to give an example. Other questions? For instance, you asked me because you had a question for me, I think.
Yes, I know.
Yeah. Yeah? Yeah, please. For sure it's okay. Thank you very much. I think I can stop the camera.